We are going to do Chapter 7 and Chapter 8 this week. Questions 1. An object is placed 50 cm in front of the diverging lens of focal length 20 cm. A distance of 15 cm behind this lens is a converging lens of focal length 25 cm. Where is the final image? You are given two lenses in these questions. When the questions involve two lenses, it is always a good idea to sketch the diagram before you solve the questions, because you are going to need the positions of I1 to determine the object distance U2 for second lens. Now let us begin with the refractions through first lens. First lens gives a diverging lens. Therefore, the focal length is a negative value, which is equals to negative 20 cm. And given the object is positions at a distance 50 cm in front of the first diverging lens, therefore we have U1 equals to 50 cm. And the distance between two lenses is 15 cm. Now that you have F1 and U1, let's apply the equations for a lens. So 1 over F equals to 1 over U plus 1 over V. Substitute the values into the equations and you will get V equals to negative 14.29 cm. Now, this negative sign, it tells you that the image form is located in front of the lens, which is the same side as the object. Now, let us complete the diagram for the lens. So given V1 is equals to negative 14.29 cm, so now we have I1 is located at 14.29 cm in front of the diverging lens. And like I told you just now, I1 would be equals to O2, and we are going to need this O2 to determine the distance for U2. So as you can see in the diagram, U2 is equals to V1 plus 15 cm. Therefore, U2 is equals to positive 29.29 cm. And your givens, second lens is a converging lens. Therefore, F2 should be a positive value, which is equals to positive 25 cm. Once again, now that you have F2 and U2, let's apply the equation for a lens. Substitute the values into the equations. You will then obtain V equals to 170.8 cm. So the positive sign shows you that the image is now formed at the back of the lens, which is opposite to the positions of object. Questions 2. An interference pattern is produced when a monochromatic light of wavelength 600 nanometer is shined onto a double slit having a slit separation of 0.25 mm. Alternating bright and dark fringes are formed on a screen placed 1.5 meter from the double slits. Find A. The fringe separation. B. The distance of the 9 bright fringe from the center. C. The distance of the 9 dark fringe from the center. D. The distance between 9 bright fringe on the both sides of the central maximum. E. The distance between the 5th bright fringe and the 12th bright fringe on the same side. F. The distance between the 5th bright fringe on one side and the 12th bright fringe on the other side. Questions A asks you to determine the fringe separation. So this is a very simple question. You just have to apply the equation for fringe separation, which is delta y equals to lambda d over d. So substitute the values into the equations. You will then obtain delta y equals to 3.6 times 10 to the power of negative 3 meter. Questions B asks you to determine the distance between 9 bright fringe from the central maxima. So let's apply the equations for bright fringe. Y equals to m lambda d over d. 9 bright fringe is equals to 9 ordered bright fringe. Therefore, we have m equals to 9. Substitute the values into the equations. Now you have y equals to 3.24 times 10 to the power of negative 2 meter. Question C is asking for the distance between 9 dark fringe from the central maximum. So let's apply the equations for dark fringe. Y equals to m plus half lambda d over d. Now remember, 9 dark fringe is not equals to 9 order dark fringe. It is equals to 8 order dark fringe. So therefore, m is equals to 8. So substitute the values into the equations. You will then get y equals to 3.06 times 10 to the power of negative 2 meter. Question D is asking for the distance between 9 bright fringes on both sides of the central maxima. Let's have a look at the diagram. If you look at the diagram, you will see that the distance between 9 bright fringe on both sides is actually equals to y9 plus y9. Therefore, apply the equations to y9. You will then obtain 6.48 times 10 to the power of negative 2 meter. Question E wants you to determine the distance between 5th bright fringe and the 12th bright fringe on the same side. Now let's have a look at the diagram. If you look at the diagram, the distance between 5th bright fringe and the 12th bright fringe on the same side is equals to y12 minus y5. So just apply the equations, y12 minus y5. You will then obtain 2.52 times 10 to the power of negative 2 meter. Questions F, which is the last questions in questions 2, it asks you to determine the distance between 5th bright fringe on one side and the 12th bright fringe on the other side. Once again, let's have a look at the diagram. So if you look at the diagram, now, given 5th bright fringe and the 12th bright fringe, they are located on the opposite direction. Therefore, the distance between them is equal to y12 plus y5. So just apply the equations y12 plus y5. You will then get 6.12 times 10 to the power of negative 2 meter. So when it comes to calculating the distance between fringes, you have to read the questions carefully. It is not always equals to delta y, which is lambda d over d. You have to read the questions carefully and see what are the distance that the questions want. Questions 3. The second order maximum produced by a diffraction grating with 560 lines per centimeter is at an angle of 3.1 degree. Determines the numbers of maximum that can be observed on the screen. State and giving reason, what would you expect to observe if a grating with a larger numbers of lines per centimeter is used? Question 8. Determines the numbers of maximums that can be observed on the screen. If you look at the questions, we don't have enough information to solve the questions because we don't have the wavelength of the incident light. So let us determine the wavelength. But again, before that, let's analyze the question first. So given second order maximum means that our n now is equal to 2. And don't forget to change everything to SI unit, especially the numbers of lines per unit length. So given n is equal to 560 lines per cm, if you convert it correctly, you are going to obtain n equals to 5.6 times 10 to the power of 4 lines per meter. So now that you have capital letter N and small letter n, let's determine the wavelength. By using this equation, d sine theta equals to n lambda, d equals to 1 over capital letter N. Therefore, we now have 1 over n sine theta equals to n lambda. Substitute the values into the equations and you will get lambda equals to 4.83 times 10 to the power of negative 7 meter. Now that we have the wavelength for incident light, let us proceed to solve the questions. So to determine the numbers of maximum that can be observed on the screen, let's assume theta equals to 90 degrees. And again, apply the equations 1 over n sine theta equals to n lambda. Substitute everything into the equations and you will obtain n equals to 36.97. Remember, n, the numbers of order, it cannot have decimal point. So you just round up the value to 36 order. So as long as it hasn't reached 37, you cannot round it up as 37. You need to round it down to 36. So the numbers of maximum that can be observed is equal to 2n plus 1. So the final answer is 73 fringes. Question B is an explanation type question. It asks you what happened if you increase the values of capital letter N. So since you're still using the same incident light, therefore lambda is constant. And let's just assume theta is equals to 90 degrees. Okay, so we have to make it constant for both cases. So 1 over n sine theta equals to n lambda. Sine 90 equals to 1. Therefore, we have 1 over n equals to n lambda. So let's check the relationship between capital letter N and small letter n. So according to the equations, if lambda is constant, then n is inversely proportional to the numbers of lines per unit length. Meaning that when capital letter N increase, then the numbers of order will decrease. So it means a grading with more lines per meter, it could produce less orders. So less fringes can be observed on the screen. So that's all for week 18. I will see you all again tomorrow.